talk about distance formula first. Does anybody actually remember the distance formula?
Well, actually, since you don't remember it, I guess I'll just drive it for you. Let's have fun of this. So you got this little grid here that I want you to plot some points on. One of them we're going to call x1, y1. And one we're going to call x2, y2. This length right here would be the distance between them.
Okay. Now, slanted lines give you a great opportunity to draw right triangles. They do.
Right triangles open up here. Where do they open up? They open up diagonally here. They do. In this case, a squared plus b squared will equal b squared. Or b squared is a squared plus b squared. You just need to figure out how you can label these lengths.
Or how you can not really find them because you don't really have real points up there, but you have labels. And you know certain things. Like, you know, if this was a 5 right here and a 2 right here, how long would this be?
If this was a 5 and this was a 2, how long would this be? Talk to me! If this was 5 and this was 2, how long would this be? 3. What'd you do? You took away this guy from that guy, didn't you? This is x2 minus x1. That's what it is, isn't it? Now, the height of this triangle, if this was 12 and this was 3, how long would this line segment be? This is 12 and this is 3, how long would it be? 9, what'd you do? You do y2? Exactly, you did y2 minus y1. Those are things you can plug into the Pythagorean theorem, aren't they? So d squared must be a squared, which is this guy, x2 minus x1 all squared, plus b squared, which is the other guy, y2 minus y1 squared.
That's your distance squared. How do you counteract squaring? Square rooting.
I don't know if you knew the distance formula and you were just being secretive. But there it is.
And all it is Pythagorean theorem. It's nothing more. Which is how they're supposed to introduce this in 8th grade. I don't know, maybe 8th grade math teachers didn't do that with you, but they're supposed to. They're literally supposed to show you that in 8th grade. Guess not. I usually show it to you in Algebra 2. So there's your distance formula. We'll talk about midpoint formula when we need to, but that's not a hard formula. So find the distance between the points 1, 3, and 5, 6. All right. Somebody help me do the setup.
Okay, I'm talking to myself today. Those of you that need it, labeling helps. You do x minus x, you do 5 minus 1 all squared, plus 6 minus 3 all squared.
And then you do the math, kids. It's not that hard. What's a 5 take away a 1? What's a 4 squared? 16.
What's a 6 take away 3? What's a 3 squared? 9. It is 16 plus 9. 25. What's the root of 25? 5. 5 units.
Emily?
It is Emily. It is. Emily went over the homework from whatever day that was. Good day. Monday. I know that the project notes, the videos do not have audio. School on the talking school. I'll make sure those are already done. And I know you're saying this is making.
You look like you've been fighting something off.
They cut into my eardrum yesterday.
Oh, it's been bugging you for a while, hasn't it?
I keep having infections. Now I have fungal infection.
Wouldn't matter if there was no audio or not. You couldn't hurt it.
I can literally, and I can't, I'm not even talking too loud. No one can hear me because I'm afraid I'm like blowing people's ears off when I talk.
You're wearing a mask, you can pretty much talk as loud as you want. You haven't quite gotten figured that out yet. All right, so there's, I guess it's one of the examples. It sounds to me like the hard part is y'all have to remember it. Please don't be this quiet for me. Please start talking to me. Why don't you guys do this one? I'll put that back up for Emily. I'm going to scan back for Emily. You guys work on this one while Emily catches up. There's the distance one, Emily. You arrived it. There's the bottom is distance one.
So you at home, you're doing that one example there I haven't done yet on distance one.
I don't think it happened on this one, but the opportunity is some kind of library shows up too. Nobody wants this one. Start over.
Yeah, I can't hear you when you're talking now.
Oh, I think you're talking to Second school. Packers would be 0.2 and 0.9. Finally get that down. 58.
Huh? Actually, I was going to go over this one. You can do one, you can do all of them. All right, so if you're at home, you didn't get Route 58, this is for you. Or if you're in this room, you get Route 58, because I didn't look at everybody's paper.
Lauren, you made a common mistake. A lot of kids do that. I've noticed that over the years. A lot of kids do that. She labeled hers XXYY. It's ridiculously common. You know better though, right? It just happens. It just happens. -1 minus 2 squared plus 3 minus the -4. Jaden, you made the other common mistake. Messed up on the -1 minus 2. That's the other common mistake. Anyways, that's a -3. That's a 7. -3 squared is 9. 7 squared is 49. And you get root 58. I would not expect to see all of that work for distance problem. Maybe show the setup. That's about it.
Because most of that stuff can be done in your head, and it should be done in your head. It really should be. You should eventually get to the point where you don't even write anything down, because it's really not that hard. I mean, when I look at a distance formula, I just think about, I don't even think really about the formula. I do and I don't. I think how far apart are 2 and -1. I don't care about signs. How far apart are 2 and -1? Don't worry about signs. How far? They're 3. What do you got to do with that 3? Square it. You're going to get 9, aren't you? Just like you would if it was a -3. You need to be listening to me. The signs matter. It doesn't matter if you square a +3 or -3. It's about distance between them. That's what you're squaring. The same thing with y. I think about how far apart are 3 and -4, and I get 7. Now, I don't actually sit there and kind of do the subtraction operation. I just think about distance and I square it. It's really easy if you think like that. No, don't be getting all caught up on this thing being positive or negative is what I'm trying to tell you. It doesn't matter. The squaring makes it positive. And everything will work out. That radical does not simplify. We're not doing midpoint. We're doing distance. There's no halving.
Oh.
It is y2 minus y1. So it is 3 minus the -4. I guess midpoint's probably up next. Oh, we haven't even talked about midpoint yet, have we?
I was just looking at the original formula, which everyone has correspondence.
The original formula has a half in it?
That's why too.
That's y2. Yeah, that's y2. So you got a couple of these in your homework. Consider these 3 points. Find the length of each side of the triangle, and then verify that it's a right triangle. And then find its area. So we're supposed to plot these 3 points. And you're kind of doing this on a freehand grid. So you don't really have no idea if it's a right triangle or not. It might look like a right triangle. It may not be.
Try and keep your tick marks relatively same scale. There's A. B is at 2, 3. C is at 3, 1. Oh. There's my little triangle. Does it look like it might be a right triangle? Might be. That angle of B very well might be 90 degrees. But here's kind of how you prove it's a right triangle. It's not too hard to do. Part of the process is finding each side length. Okay? It really is. Finding each side length. So A was at -2, 1. And B was at 2, 3. I'm just going to kind of shortcut distance here. I'm not going to sit here and write this out. But the length of AB, you don't put a line segment over what you're talking about length. So you just say AB. It's been a while since I taught geometry. But that, without the line segment over, it says that is the length of AB. How far apart are the x values? 4. We can do that 4 in distance formula. Square, right? You're going to have a 16 in there. And you can add to it the difference in y. How far apart are the y values? 2. Well, that's 4 squared. That's 4 when you square it. This guy ends up root 20. All right. Now we got to find b to c. How far apart are the x values? 1. What do you do with that 1? Square. I guess I'll write that at home. How far apart are the y values? 2. What do you do with that 2? Square. That ends up being root 5. The other length I need is AC. How far apart are the x values? 5. And I square. How far apart are the y values? 0. But I square. All that's in there that matters is 5 squared, which is 25. And what's the square root of 25? 5. I didn't show all the steps. Were you following along what was going on? You don't have to do all the steps. It's about distance between x and distance between y. That's all it is. Square root. So there's our 3 side lengths. What's C say here? On the next slide, let's say we need to do. Let's say verify it's the right triangle. I will copy this thing and put it on the next slide. This is for me. I woke up here. There's my lengths. Now, if something is a right triangle, what has to be true? What theorem has to be true? A squared plus b squared equals c squared must be true. Which one of those 3 lengths is or has the potential of being the hypotenuse? Huh? Yeah, which one's C is what I'm asking. C is definitely the hypotenuse. This is your hypotenuse. Which one of your 3 lengths, root 20, root 5, or 5, is going to be the potential C? The 5. It's the bigger of the 3. This guy right here might be the hypotenuse. I'm using the word might be. Why am I using the word might be? I don't know if it's right triangle or not, but of all 3 candidates, that's the most likely, isn't it? So now I just plug the numbers in the Pythagorean theorem if I see if it's true. So one of my legs is root of 20. Doesn't matter what A or B are. Never did before. Doesn't matter now. So, if I was a little confused, I just call the first one A and the second one B. Plus root 5 squared must equal 5 squared. Now, when you square those radicals, what do you get? Number inside. So we'll have a 20 plus a 5 equal to 25. Is that true? That is true. All day long, that is true. So this is a right triangle. You don't have to write out the word triangle, kids. You draw triangles. Squiggle. What was D? Find the area?
I'm actually going to go back to what we did. What did we learn about angle B? It's 90 degrees. Well, I don't know that's where the right angle is. What's it opposite of? It's opposite of the hypotenuse. Pythagorean theorem ended up being correct. It is opposite of the hypotenuse. All right? I wish I had some more free space on the next one. For you guys at home, I went back, and this is where I'm going to do D, find the area. What I'm going to do is I'm going to redraw the triangle so it makes more sense to find area. I know that's the right angle. You talk about height. When I measure my height, am I leaning? No, I'm standing straight up with the ground. What kind of angle do I form with the ground? I form a right angle, hopefully. Unless one of my legs is shorter than the other. Hopefully I form a right angle. So I care about this length and this length. Why do I care about those two lengths? Base and height. I care about base and height. So BC had a length of root 5. AC had a length of, sorry, AB, not AC. I don't want A. I want AB. No. AB had a length of root 20. And of course, the other thing I got to know is how you find the area of the triangle, which is what? Why not base and height? That's just simple substitution. One of my legs was root 5, and one of my legs was root 20. Try and do things without a calculator. What is a root 5 times root 20? What's 5 times 20? It's 100, isn't it? This is 1/2 the root of 100. What is the root of 100? Yeah. Why are you all so quiet? Talk to me. Have I been yelling at you this year? Not really. Talk to me. What were you scared of? That you'd be wrong? Everybody's wrong about something at some point in their life. I'm sure I'm wrong every day about something. I'm just too darn proud to admit it. It's 5 and everything's said and done. Emily, I can't figure out if you're tired or they got you on good drugs. I hadn't figured it out yet.
I'm on good drugs.
You're on good drugs? Did you drive?
Yeah.
Oh, God. Don't do
My
that.
sister.
With your sister. That's been recorded.
Brian had to. They put me to sleep yesterday.
I'm sure they did. I hope you feel better tomorrow. All right, this is midpoint. I honestly don't know how or why anybody would try to derive midpoint formula with anybody, because it's a common sense formula. Midpoint means you lie where? Middle. Okay? Now let's say that Savannah is kind of like middle height between Lindsay and Emma. So if you knew Lindsay and Emma's heights, what would you do? Add them together, and Savannah's in the middle. What would you divide by? 2. That's how you do midpoint, kids. Midpoint means middle. That's all it means. Middle means average. So if you need a formula for midpoint, this is where it is. And it's the midpoint between points. You have your x's, you add them together, divide by 2. You have your y's, you add them together, you divide by 2. That's all midpoint is. And you don't have to label. In fact, you don't even have to label x1 and x2 in distance formula. None of that matters. It's just x minus x. This is x plus x because it's finding average. Or distance. It doesn't matter. Distance doesn't have to be labeled either. I just do it because kids freak out if I don't. You do not have to label. You do not have to call 1x1 or 1x2 on distance formula. Because even if you get a negative, what's going to happen to it? I'm squared in what? Positive. It doesn't matter. It doesn't matter.
All right, so we're tasked with finding the midpoint of this thing. So what's our x values? 4 and 2. Now, by the way, this represents an x value and a y value. What are our y values? -2 and -5 over 2. And then you reduce, kids. I'm trying not to do this calculator because if you type this in a calculator as is, you're going to get the wrong answer, aren't you? If you type 4 plus 2 divided by 2 in the calculator as is it going to give you the right answer or the wrong answer? Yeah. If you haven't used a calculator to do this in one step, you better use pencils. You better, or it's going to be wrong. You shouldn't be using a calculator though. Anyways, 4 plus 2 is 6. 6 divided by 2 is what? 3. -2 minus 5 is -7. I guess you could write -3.5 if you wanted to, but you don't need to. We're not going to plot points, because you should know how to plot points. I mean, you just did a project where you learned a whole bunch of points. So you don't know how to plot points.
But that point right there is smack dab in the middle of these two. Is it actually worth talking about if we plotted points? Because there is something I could talk about. Never mind, I will plot points. There is something I could talk about here. So there's 4, -2. There is 2, -5. And the midpoint was at 3, -3.5. About right there. Weird. Oh yeah. Emily, you're not tripping. That's why. It's already plotted for me. I had a little hidden box covering that up. Still there. I can't seem to get it. Anyways, there they are. They're plotted. There is actually something worth talking about here.
How many years did you rise to go from the bottom to the middle? You went from -5 to -3 now. What'd you rise? 4.5, right? How about to go from the middle to the top? Would you rise again? And then from -3.5 to -2. Would you rise again? 1.5. Notice how those are constant. The run is the same way. Would you run 1 to get to the middle? Would you run again? 1. It should be that way, shouldn't it? The rise will remain constant.
Don't forget about little concepts like that when you're looking at problems too. Little concepts like that pay off. The midpoint segment of AB is 3/4. If B is -3.9, what are the coordinates of A? Bummer, didn't finish, but it's in your homework, and that's why I was talking about what I just talked about. Maybe draw it out. Might help. Go enjoy your day. And wake up.